Okay, let me give you guys some more practice. So find the arc length from 0 to 2. So find this arc length here. It looks simple, but it's in fact not. I would expect you to get stuck on this, but have a go anyway. Find the arc length from here to here. Okay, so press pause and have a go. Okay, so the actual solution to this, we're going to leave it to another day, because at the moment our knowledge of integration is still too weak. But let's try and understand why it's difficult. So here we want to find out the arc length of this, but the formula for the arc length is given by this, and we need to find the derivative of this. So finding the derivative of this is straightforward. Is this. But then if you look at this here, once we've got the derivative, we need to square it. So the next step is we need to square it. And then the next step here, we need to add 1. And then once we've added the 1, we need to write it in the form of something squared, because later on we need to square root it. So this square root will cancel out with this. Well, hang on, let's start again. We've got our function. We need to find the first derivative. The first derivative of this is this. Now we need to square it, so squaring it will give us this. Now we need to add 1, so that will then give us this. Okay, but once we're here, we need to write in the form of something squared. Okay, our normal routine is to once we're here is to write it in the form of something squared. This here is our normal routine. Okay, but the thing is, how would you write this? How would you write this in the form of something squared? Because we can't really, you see, if you have something like this, -1, then there might be something that you can do. Maybe you can do something like this, x squared, x, and then minus, but you could do something like this. This here might help, but it's still not in this form, squared. The point is that from here, we can't write it in the form of something squared. That's why we have trouble solving this problem here. We need to rewrite this in the form of something squared, but we just can't do it once it's in this form here because of this +1 here. Well, okay, let's just try and put this into the formula anyway. So at the moment, this thing here equals this. Our normal routine would be something squared, but we can't take this root. We just don't know how to do it. So let's just try and put this into the formula anyway. So the formula, let's put this into this thing here. So at the moment we've got, this thing here is this thing here. Let's just try our luck and just try and put this into here anyway. So that will then take us to this. Okay. Let's try and integrate this. Remember, our knowledge of integration at the moment is still too weak. So how would you integrate this? So our normal routine would be to rewrite this as something to the power of a half. As something to the power of a half. So this is our normal routine. Now we need to integrate this. Now how would we integrate this? Because if you so you're looking for something that when you differentiate it, it will give you this. And our normal routine would be to integrate. Our normal routine would be to do this. Make our initial guess to be 1 more than this, so that would be 3/2. So what goes in here would be this. Hang on. So the thing is, when you differentiate this thing, it will give you this thing here, 3/2. The bubble here stays intact, and then this gets minus by 1. That will then give you this. But then we need to times the derivative of the bubble itself. So that will be 8. That would be 8x. Okay. But the thing is, we've got, you see, this here matches up with this. But the thing is, you've got this x lingering around. You see, this here is actually, well, we don't have enough knowledge to integrate this. You see, if you were given something like this, then you could integrate, because when you differentiate the bubble itself, it becomes 8x. There's a convenient x over here. But if you see this one here, we cannot integrate, because when we come to time to the derivative of the bubble, we will get something. You see, given this here, yes, you can integrate this. We have enough knowledge to do that. But without the x here, we don't have enough knowledge to integrate this. Down here, you've been given this x here, so you could easily integrate this. But this here, you cannot integrate. Well, we don't have enough knowledge to integrate this. So this is why we're having trouble finding out the solution of the arc length there. Okay. The point of this video is that up until now, when you're asked to find the arc length, up until now, all the problems given to you, you could easily rewrite it in the form of something squared. So all the problems given to you in the past is that you could easily, conveniently rewrite it in the form of something squared, so that later on this square root will cancel each other out. But in this case, well, in the case of f of x equals x squared, we're going to do our stuff, and then later on when we come to want to rewrite it in the form of something squared, we just can't do it. That's why in the past you've been given something that you can easily rewrite it in the form of something squared. The reason why you're having trouble with this problem is that in the case of f of x equals x squared here, we cannot rewrite it in the form of something like this. That's why we're having trouble. In the past, all the problems that you've been given, you could conveniently rewrite it in this form here. In this video, we couldn't write in this form here. Okay.